The rational zero theorem gives me a way to identify possible zeros of a polynomial. If I have a degree n polynomial, every possible rational zero, remember a rational number is any number that can be written in a fraction form, any possible rational zero will have the form p over q, where p is a factor of the constant term and q is a factor of the leading term. Let's look like this with an example and we'll make some sense. So I want to find all the zeros of this polynomial. So if I'm looking for the zeros of this polynomial, I'm looking for where 0 is equal to 10 over 7x to the fourth minus x cubed minus 7x squared plus 5x minus 5 sevenths. Now the first thing that I'm going to do is make this easy on myself and multiply both sides of the equation by 7, because multiplying by a constant won't change the values of the zeros, but it'll get rid of these fractions for me and make something easier to work with. So 7 times 0 is 0. 7 times 10 over 7 is 10, x to the fourth. 7 times this is minus 7x cubed. 7 times this is negative 49x squared. 7 times this is plus 35x. And then 7 times this is a minus 5. Okay, so now I need a list of my possible zeros, because I need somewhere to start to find the zeros of a fourth degree polynomial. So our previous theorem just said, look at the factors of 5, which factors of 5 are 1 and 5, divided by the factors of 10. Now the factors of 10 are 1, 2, 5, and 10. All right, so we just go one at a time. Let's take the factor here in the numerator over these factors in the denominator. So 1 over 1 would be a 0 at plus or minus 1. 1 over 2 would be at plus or minus 1/2. 1 over 5 would be plus or minus 1/5. 1 over 10 would be plus or minus 1/10. Okay, we exhausted the 1. Now let's do the 5. 5 over 1 would be plus or minus 5. 5 over 2 would be plus or minus 5 halves. 5 over 5 would be plus or minus 1, so we already got that. 5 over 10 would be plus or minus a half, so we already got that. So this is a complete list of all of the possible rational zeros. So now to determine if any of them work as a zero, we're just going to go through and plug them in. So like start with positive 1. Positive 10 minus 7 is 3, minus 49 is negative 46, plus 35 would be negative 11, minus 5 would be negative 16. Positive 1 is not a zero because we didn't get back 0. Try negative 1. So negative 1 to the fourth is positive 1. So 10 plus 7 is 17, minus 49 would be negative 32, minus 35 would be negative 67, minus 5 would be negative 72. So that's not a zero, so we used up all of those. Okay, so now let's do positive 1/2. Guess what? Positive 1/2 is going to work as a zero if I plug it in. Once I know that it works as a zero, I can now divide it out with synthetic division to get a lower polynomial. So 10, negative 7, negative 49, 35, negative 5. Bring down the 10. Half of 10 is 5. Add going down, we get a negative 2. Half of negative 2 is negative 1. Add going down. Half of negative 50 is negative 25. Add going down. Half of 10 is 5. Remainder 0, just what we were expecting. So that means this polynomial, once I multiply by the 7 and get this form, factors into x minus this 0, x minus a half, times 10x, go one lower than the fourth, so 10x cubed minus 2x squared minus 50x plus 10. All right, now we used positive 1/2. Try plugging in negative 1/2. Now, by the way, I could plug it in here, see if it's a 0 here, and that would be shorter. Guess what? My next one's going to be at 1/5. So let's plug in 1/5 and do the synthetic division on this. So 10, negative 2, negative 50, 10. Bring down the 10. A fifth of 10 is 2. add going down, we get a 0, 0, negative 50, negative 10, 0. All right, so that means that now we're factoring into x minus a half times, let's move this out of the way. Oops, go back. Oh, I can't seem to move that. X minus 10 times x minus 1/5 times 10x squared, because we go 1 lower than the x cubed, so 10x squared minus 50. Now notice I can factor a 10 out of this, so I'll pull the 10 out front, and I have 10 times x minus a half times x minus a fifth times x squared minus, I pulled a 10 out, so that's a 5. This is the difference of squares. X squared minus a squared factors into x minus a times x plus a. So I can factor this guy into x minus square root of 5 times x plus square root of 5. So find all of my zeros. Well, there are only 2 rational zeros, 1/2 and 1/5. And then there are 2 irrational zeros, positive square root of 5 and negative square root of 5.